Okay, good morning, class. I'm sorry for my voice, my weak voice today because of the cold, but I'm trying my best to lecture on 5.3. We have done 5.2 last time, right? So I look back and we did finish that. Do you have any question on 5.1 and 5.2 before I move on to 5.3?
No.
Okay. So for 5.3, you learn more about probability, but this time you will learn new probability. Okay, it's not like 5.2 anymore. This probability have the name we call conditional probabilities. As you see at the bottom, the objectives that we are having for 5.3 is find conditional probability, and you will learn how to determine if the events are dependent or independent. So the word dependence and independent, we have talked a bit in 5.2 already, right? So independent, like they're not like really like related to each other, correct? So that's kind of independence. But for this section, you would make a test on it, which is you will find a probability to see if the probability of the A event and the probability of B events, are they equal or not equal? So then you can determine if they are dependent or independent. So you will see the example later. And you're going to use the probability to determine if there is a relationship between variables or not. So this kind of again relate to dependent or independence, and you will know how to identify that later on. So first, let's look at this table. This table we did some in 5.2, but it's not a lot. It's not a lot situation. So this example talking about different situation, you will learn like combine chapter section 5.2 and new section, which is 5.3 today, which is you will learn about probability, conditional probability. Okay, so let's look at this example. So this table shows that marital status and educational level for a random sample. As you notice, we have like how many group? We have less high school and college or higher. And we have the groups of single, married, divorced, or widow. And so you add up the total, right, for both. So like again, I saying you add vertically and horizontally have to have the same number right there. When you're adding up, make sure they have to be the same. So let's see the question that the textbook asking us. So is there an association between marital status and educational level? Right, so in order to answer this question, again, you have to find probability to see like how large it is or how small it is to determine that. And the word proportions right there that you notice, proportion right here, it means probability. You find probability anyway. Okay, so for example, are college educated more or less or likely? So actually, in order to answer this question, we have to compute the probability of each situation and to determine. Again, the formulas, they not introduced us right away, but I try to show you that we will compute and maybe they have some kind of like introduction example for us to kind of get the sense of what is conditional probabilities. Here they given us a, what does it mean? The probabilities where we focus on just one group, right? We just focus on just one big group. And then you imagine taking a random sample from that group. Do you understand it? So it looks like this. Let me draw a bit so that you can imagine easier. So you focus on one big group, right? And then, and imagine you're taking a random sample, anywhere, a sample right there, from that group, from the bigger group. So let's say group A, and then you find the, to take random sample with, let's say this small group is group small a, okay, from the big group A. So we call this conditional probability, which is they given you a big group, capital A, then you will find the probability between these two group, small a and big A. That's what it means. And the word that they usually use, you will see the word given that. So let's see example, probability of a person is married, given that the person is college educated. The word given that telling you, they're talking about conditional probability, which means they're talking about this picture, okay? So you can imagine, so now big group A, based on this example, can anyone tell me what is the big group A stand for in this example? Anyone? So the big group A will be the person is college educated, okay? In this case, is college educated, let's say college educated or college, okay? College level. So that big group A. And the small a will be a person is married. So that is the example describing like that. So the word given that all the time, given that a group is all the time talking about a bigger group. So when you find probability, there will be a formula for this. I will show you later. Right now, you just need to understand the key terms like that, how they describing it. So similarly with the second example, probability of a person is single, given that the person's highest education level is high school. So can now you tell me the big group in this case will be what?
All people with high school education.
Yes, that's right. So that's the big group that you want you to focus on. And then they're talking about a smaller group, which is the person is single, right? So that means you find the probability of the people who are single in the high school level group, like that. Okay. So any question before I move on? Okay, no. Look at, they have the picture right here for us. This two picture is mean we have seen the first picture where, you remember? This first picture in section 5.2, right? The second picture is the one that we just talked about. This picture describing the conditional probability. And this picture talking about the probability that we did talk in 5.1. And this probability is theoretical probability, right? Probability. Okay, so we got these two picture. What does it mean? The first picture saying that you see that the blue color represent for people who marry. And the yellow picture represent for all college level, right? So, but how, so they have joined only this part. And we're using what is the word that you learn in 5.2 in that intersection? Anyone remember? Anyone remember? Okay. And that's right. That's and. Okay. So remember this. Don't forget to look back all the formula that I taught you in 5.2. Okay. So this picture is here. The word, the intersection is and. So, but this picture, they have, you can know the picture number 2, college and marriage. What do you think here? What do you think that the intersection? That intersection also is and, of course. However, they have a like more interpretation, which is given that. Okay. So this is and, because they have joy, they have something joy in common. So we call and. So the green part right there, they're talking all the married people who are college students, right? Or another word, in a college people or the college student group, and you will select out all the married people to find probability on it. The rest part, which is the yellow part, that the rest of them, it can be non-married, correct? Or widow, correct? Agree? So, but they're not talking about the big group of who's married, right? So the intersection, the green part right there is and, but here is the picture of the word given that as well. The first picture is not talking about the word given that. So that the first picture, that's why it's not conditional probability. But the second picture describing conditional probability, because we're talking about the big group, we're focusing on the big group, and then we take the random sample of that group. Okay. So you can read more of this example in a textbook. They do have a lot. If you spend time, you will see that there are many for you to practice a lot. Okay, so any question before I move on? Don't forget to review after you we're done with the lecture. Don't forget to review it many times. Okay, if you don't have any question, I will move on. Excuse me. Okay, so it looks like below here they describing for us. You can take 1 minute to read this these two example that I just explained in from the textbook. Okay, 1 minute. Does it make sense? See the differences?
Yes.
Yeah. So now is the application for that. And again, they're not giving us the formula yet. So now we look back by looking at the table first to see what happened. Okay, they're asking us the probability of marriage and college educated. The word "and." That's a key term that you can recognize so that you can compute easier. So the word "and." So this is look like section 5 part 2. Okay, so let's check it out. The key term, the key word is "and." You know what is "and" look like, right? And then they're talking about marriage and college educated. So let's looking at marriage group now. Marriage group we have from here, right? This line. That's marriage group. And we're talking about college educated because the word "and" describing the joint part between these two terms, between these two groups, marriage and college educated. So you're focusing on the intersection between these two. College educated, maybe here, yes, here, college educated. This box. So the joint part is where? The joint part is this box, right? 90A. That where they intersect. So now you're going to take that value is 98 divided by the total, right? Divided by total 665. Then you convert into decimal value to get a solution. You route to the, you can write both, but on the test again, I would like to see the fraction and then the decimal, at least these two. Okay. Again, so when they have the formula for R, then you need to write R, the formula out for me to see it, to see how you compute. Okay. Any question? Okay, no. So now we'll go to the second example, the word "given that" join in. Okay, same table, but this time is the word given that, and you already understand the word "given that," right? That I explained earlier. So now let's find probability of student who's married, comma, they put the commas right there, given that he or she is a college educated. So now for this one, it looks like they want us to focus on the big group, which is college educated, right? So college educated group, let's say college educated group is right here. This line, right? That's a big group. So let's see the total that they have. The total is 143. 143, the big group you put at the bottom. And then what do they want we to focus on that big group? People who marry. Marry is right here, right? We don't take total marriage because if you take total marriage, that will be including less high school and high school too. But no, we don't focus on less high school and all high school group. So we ignore that value. So we just take the intersection of marriage and college or above, right? Or college level. So the way they have joined, which is the marriage people is a small group inside the college level. So you write 98. Does it make sense? Remember the picture that I drew? So when you're done this, you convert into decimal value for me, route to 100 place. And that's all. That's how you look at it. Another word for those who like to memorize. So following given that, you can know that that will be the big group. You will write the value at the bottom. And then the marriage you write on the top. Remember the intersection. The intersection between them, like this picture. This picture is college educated. And smaller one is married. Okay, like that. The intersection of these two right on top. Any question about given that or conditional probability? Okay. So now they're giving us notation about conditional probability. The condition is here. Notation is just a bar, straight line, separate between two terms. And you will know right away. So that the probability of marriage given that college educated. So they just translate from the above sentence, right? The sentence that we just compute the probability. So take, instead of they write given that, blah, 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 they cut it off, they put the bar. In general, P of A given B. That means you find the probability that event A occurs, right? They're giving you a bigger group, which is group B, has occurred. Please stop me if you have any question. So here's the formula for you. You need this formula, okay? If you can see by eyes, like I just showed you, it's okay to directly do it, but you have to show me probably the fraction and then decimal value. If you can see by eyes, but if you cannot see by eyes by looking at the table like I just did, you should write down this formula so that you can follow easier, okay? All the time when I'm asking you, I might give you this notation first or sentences like the textbook. You will be the one who figured out what will be the event A, what will be the event B, to plug in the value from the table, from two-way table. So let's do more example. Let me show you one more time, then I let you practice. Oh, let's try to finish all of this then. If we have time, I let you practice on it. Okay, so find probability marriage or less high school. So this time they replace this group, right? They replace college level, now become less high school. Similar way. So what do? You find the bigger group you put at the bottom, which is less high school. You got this value, 125. The top part will be the intersection between marriage and less high school. So marriage here, right? Go down. So you see the intersection is right there. Intersection right here, 70. You put 70 on the top, then you're done. The intersection part is mean and marriage and less high school. That's 70 divided by 125. That's how you do it. Any question? Sorry, excuse me. Okay, no question. Okay, so same thing. We are having, so this is the way they're using the formula. It's kind of long. Okay, it's kind of long, but it's clear. For those who cannot looking at the table and do it, you can practice by using the formula this way, okay? But I believe that people prefer the looking at the table like I just did, and it's faster. It's still accurate, but it's faster. So this is you try to find separately probability of marriage and less high school. What is it? And probability of each, and then you combine them and you divide and you got the same value. You can check that out at home, okay? So now we're talking about independent events. Okay. Independent event, what does it mean? Variables are events that are not associated or called independent events. So two events are independent if knowledge that one has happened tell you nothing about whether or not the other event has happened. So they're not related, correct? They're not associated. So in symbols, we have A and B are independent events. So we're pretending A and B are independent events. It means, this is a formula for you, to testing. If they are independent event, then this happened. Then probability of A given B equal to probability of A. What does it mean? You must find probability of A given B first by using the step that I show you. Okay, and then you need to find probability of A to see what is the value. After that, you compare these two probability together to see if they are the same or not. If they're not the same, then they will be called dependent, right? Or not independent. If they do the same, then you conclude these two events are independent. So this is a formula how to testing the independent events. Okay.
Can I ask a question?
Okay.
So this was something, I think it was just like the wording of it in practicing the homework. It was a question. I don't know if it would be easy if I shared my screen to show the exact question.
About independent events?
Yeah, or I actually asked it a little bit late. It was more about associated events.
Associated event.
Mhm.
You want like share like yeah, you can share. Let me.
Is that okay? Okay.
But is it homework or something?
Yeah, it was for homework for the.
So homework. So then not this time. You can ask me later on.
Okay.
Okay. So now is the lecture time. So sorry.
Okay.
Yeah. Just keep that in mind. Later, ask me. Okay.
Sure. Thank you.
Yeah. So example 5 about independent events. Here is the example. So hope everyone already seen card, how to play cards, or from the standard deck, or playing cards. It's been a long time. So I can give you, let me see. I have this picture just to remind everyone and remind me how the cards look like. So everyone can see it, right? So cards, we have 52 cards actually, and we have how many shoots? We have spade, clubs, diamond, and heart. So total we have 13 cards for each shoot, right? However, you look at the color, we have spade and club are black, and diamond and heart will be red. So if we're talking about black color, so the total of the card will be 26. You add 13 with 13, right? And red color will be 26 as well. So, and the question asking what? So they want us to find, okay, are the events, the card is a club, and the event, the card is black, independent. So if they're asking this question, what do? They have to find the probability of A given B equal to event A, right? So in order to do that, they have to make a test. They have to find probability for each and then combine like they do right here. So probability of card is a club. A club is the black color, right? A club, this shoot is like total. If we're talking about only the cards is club, then we got total is 13 cards club, right? Divided by the total out of total of the card. Similarly, with the probability of the card is black. Like we have black, we have club and spade. Right, let me check. Spade and club, you add up, it will be 26 out of 52. Right? So you reduce, you got these two values. And what about probability of the card is a club given the card is black? You can do two ways, okay? So this is one of the way. We are having card is club, given card is black. So card is black will be the bottom part, which is 26, that's group. Focusing on a club only, we have 13, all right? So we have 1/2. So now you compare this. Look back the formula. We have, let's say the event, this is the event A given B, right? The formula is testing A given B have to be equal to P of A to test if they are independent. So now compare. This we have 1/2. Based on this example, will it equal to club? This is event A, right? It's not equal to 1/4, right? So this, we are saying that if they are not equal, what does it mean? So if they equal, they will be independent, correct? So you can conclude another way is what you can do is if I change my letter grade, if I change my event value, then I can do the test similar way. Let me try a different way. If I make event A is let me see, a different name. So if I change to a different name, then you could do the same thing. Let me change to diamond or heart, for example. Okay, card is, let's say diamond for the diamond. Then you got the same value, right? Got the same value. And if I say card is black, then it's not related, correct? So diamond is red. So, and we have black. So we better write this to be red because we're talking about a big group. Red is 26. Right? Big group red is a red color, red shoot. Red shoot, we got two type, right? You got total is 26. And we're focusing on diamond because in here is, you know right away is half is diamond and half is heart. So diamond, you know right away is 13. You can replace in with this situation to see it, right? you just practice by giving you different example like this so that you can practice to test if they are independent or not. We cannot see by eyes actually, so we have to compute and testing like this to see. Any other question about this testing independence event?
So here you're using, so the example you gave, because 1/4 does not equal half. So
they're not independent.
Okay, because if it had been half equals half, such as like a red, a red card or something, then it would be independent.
Yeah.
Okay.
So for this situation, you see that the event A is a club is not as same as not equal to probability a card is club given that card is black, right?
Yeah.
They're not the same. They're not the same. It means they're not independent.
Okay.
They're not independent. That means they are associated. Understand?
Yes. Thank you.
And I did give you another example for diamond in red color. You can practice at home to testing it to see. But it just looks like the same value, right? Because each shoot is just 13 cards. Red is 26, black is 26. You can, it's just different name, but different same value. Go back to this example again. So, but they have different question. They're testing us. Are the events person selected has a high school education and person selected is divorced, independence. So to testing that, you have to imagine is look like P of A given B is right here, right? So high school will be probability of event A based on the formula. You have to test this too. When we're testing it, we found that these two values is not the same. If it's not the same, it means it's not independent. That means they are associated. In order to find probability of high school given divorce, we did already, right? We're focusing on a group divorce, which is 84, you write at the bottom. High school and divorce, you find it on the top. High school where right here. And divorce. They join as the 59, you write 59 above divided by 84. Okay, that's how you find that probability. So now probability of high school total is 397, right? Because it just focus on just high school students out of the total of the students, which is 665. And we have 0.597 for that one. Okay. Does that make sense? We're testing it to see it. And that's all, applying both finding probability, and then you found, but based on the equation, the formula that are given to us, and you can tell they are not independent because they're not the same value. Okay, so if they are independent events, what happened? If they are independent event, after you testing dash two event, and you conclude they are independent, for example, and when they have extra question like this, they have to question what is the probability of A and B, pretending event A and event B are independent. All right. let A and B are independent. Then what you want to have, probability of A and B will be equal to probability of A time multiply probability of B. This word and will be different if the event A and event B are associated, correct? You only take the joy part between these two and you're done. However, if they are independent, then you have to doing the multiplication between probability of event A time probability of event B. Be careful, okay? If this on the test, then you have to be careful. You have to do the test like this process to see it and combine. All right. Any other question? Okay, so no question. Okay. This a bit, okay. This is more about independent events now. So what is it? Gender of babies. Suppose 49% of babies born in the US are girls. They're not talking about in a family anymore, right? They talk about the entire, babies in the US are girls. So let me notate this. They given us 49% of baby in the US are girls. They given us the probability of the girls. So each girl look like they have 49% chance born is girl in the US. So next sentence they said what? A couple has 2 children. Okay, has 2 children. Okay, it means you don't know it's like boy or girl in that, for each couple in the US, right? So what do they want us to do? They want us to find, let's see, boy or girls, find boy or girls. If they want us to find boy or girls, then what do? So for each couple in the US, if they got 2 children, but they want us to focus on probability of 5 boy or girls, then you know right away the chance that they're going to have. So that equal to the probability of boy or girl, so 2 children, right? It means the first baby, first baby girl, right? Should be girl. And they want us to find the second one is baby girl as well. So for this case, what do we do? So they are independent events because they're talking about the entire each baby girl in the US. They have 49 chances. And in each couple in the US, they have 2 children. So it's like they're not associated. So you have to using this formula to compute the probability of boy or girls in the US of each family. So in order to do this, we know that these 2 are independent. You have to multiply it by using the formula of independent events, which is provide previously, right? Remember? So what you're going to do is you take probability. Let me draw the line right here. Probability of first baby girl multiply probability of the second one. the second baby girl. So each baby girl have 49% chance. So you should convert this into decimal in order to multiply. 4.49 times 0.49. You compute this, you got the value 0.24. Another word is like 24% chance of a family or a couple in the US has two children, both are girls. That's how you compute that. Similarly, if I give you different question, I'm talking about boys in this case. So what happens? So based on what they given us, they got 49% of the baby born in the US are girls. So what is it imply? That imply 51%. So pretending the whole world is like 100%, all the time we're talking about 100% only. We're not talking about more than that. So if they're giving us 49% chance that are girls already, so you can figure it out, it's 51 chance will be the baby born who are boys. But if they have the question like relate to boys, then you do the same thing, same step with doing the girls. If I say, what is the probability of both or boys? What do you do? Class, anyone?
And you do 0.51 times 0.51.
That's right. Yeah, you got a value. That's correct. That's how you do. You compute for independent event like this case. Or even the first one is boy, the second one is girl, you multiply the same thing, right? You got 0. If the first one is boy, the second one is girl, then you will take 0.51 times 0.49 for that case. That's how you do in this independent event like this. Any question before I move on? Okay, no. Okay, they have this example too. 5 probability of the first is a boy and the second is a girl. So what do? They take probability of the first is a boy, they multiply with the probability the second is a girl. Don't forget P represent for probability, right? P here, P there. Some of you might miss, some of you when you're writing this, you might forgot capital P. That means that's nothing. So you must write P, capital P represent for probability of a person, okay, of the event. Regarding that value, you round this up to be 0.25, okay, or 25%. Good job. What is it here? This is another example. They said example, okay, another example. Okay, let me see. According to a Wall Street Journal survey, they've given us 70% of consumers prefer to shop online rather in person at their favorite retailer. So from here, from the first sentence, you can imply what? You can imply 30% do not like to shop online, right? Dislike online. Suppose, so they're talking about only three consumer only, okay? They're focusing on 3 consumer are randomly selected with replacement from the population of the consumers. Okay, question number 1. So we have 2 key terms here, 2 data that you need to record. So 70% like to shop online. And we're talking about 3 consumers. randomly selected. Number one, what is the probability that all three prefer to solve online? All three. And all three, okay? Again, this example similar to the boys and girls, so we can figure it out right away. They are independent events because 3% they're not associated. Three different people, okay? So in order to find probability of all three prefer online, let me write a shortcut. Let's see. Let me scroll it down. If we have, just remember 70% they like to solve online, 30% they will dislike. They talk about three consumers, so that would be, the probability of the first person like to shop online, okay, and the second person like to shop online, and the third person like to shop online. If we are writing as the formula, right, it will be like that. So let me scroll down, just have space. If I have space to write it for you. Okay, this is what I meant. Okay, that means the first one like to shop online, and the second one like to shop online, and the third one like to shop online. So three, right? So they are independent. You multiply them all together, you got a value. You're done. Box it. Question number 2. Question number 2, they said probability of none prefer to shop online. So here they're talking about 3% again, right? Select 3 randomly. If none of them do not like to shop online, what happened? Again, they are independent. The first one do not like to shop online, and the second one does not prefer online, and the third does not prefer online. Again, you multiply them all together. See that third 0.3? We know this because we imply from what given, which is 70% prefer to shop online. That means the rest, which is 30%, will not like to shop online. So now we got that value. So what is it here? Number 3 question is probability of at least one prefers online. At least one, it means one or more, right? One or more like to do that. So it means we have one prefers online, or 2 prefer online, or 3 prefer online. So now this is not and anymore, it's or, right? So in order to do the shortcut, because we only talk about 3 consumers. So the best way is what? We are using complement rules in this case. Okay, so in other words, we have at least one prefers online, at least one, which is 1 and above, 1 or more, 1 or 1 or more. 1 or more is mean what? More here is maximum is 3 only, right? Because we're just talking about 3 consumers. So 1 or more, another word, this will be 1 like to shop online, or 2 like to shop online, or 3 like to shop online. Understand? Because we only have 3 consumers, so that will be the case. And what we're going to do is, because if you take each one, it's very long, difficult. So the best way is, because we already know that 30% is non-preferred. So what you can do is 1 represent for 100%, which is the whole thing. You take away the probability of non-prefer online, then you will have the value for 1 or more like to shop online. The non-prefer to shop online, which means we have we have talking about the first person do not prefer online, and the second do not prefer online, and the third do not prefer online. So that is for probability of none prefer online. We got that value and we take the difference from 1, then you got the value is 0.973. In other words, I think we got that value on the second example. None prefer to shop online right here from number 2. You take that value and then do it so that you don't, have difficulty of compute more work. Okay, I think this is all. It's done for 5.3. Again, all of this example is from textbook, and there are more examples from textbook about all of this. So what you can do is, to understand this more, please read textbook. Yeah, on 5.3. Excuse me. So the lecture is done for the day. And section 5.4, I did recorded already, so you can check that out right now. If you have time, check that out, and then have question, ask me, okay? Now, do you have any question on 5.3 so far? So quiet does mean no, right? So let me stop recording. And you can start move on to, let me stop recording first.